Hello and welcome back. In this video, we'll focus a bit on explainable AI, in particular for classification. We look at the explainable boosting machine in this form. Remember, before we used a single decision tree. Like we have a similar video and notebook exercise where we used a simple decision tree classifier, just a single tree. And when we fitted this model with the data, we saw that this is a fairly complex tree. It's understandable sort of in principle, but of course we can see in practice we would never really be able to follow how a single decision was made or what are the major drivers of the influence of the classification result. And also the single decision tree classifier is the most performant classifier. We would use other methods and they become inherently less interpretable. And this is where the other packages come in, these so-called white box methods. One of them is the explainable boosting machine from the InterpretML package by Microsoft. It supports a range of explainable AI tools, in particular also one that is used for classification. Essentially, this is a different class of model. It's a generalized additive model, and it was also pairwise interaction, so this is why it's abbreviated VA squared. And you will use again the adult dataset that focuses on a binary classification task, whether or not a person makes more than $50,000 US per year. And the data are taken from the 1994 census and described in this paper for the first time. The data consists of a number of categorical and numerical features, and we can access them directly using the pandas functionality. So here we import all the relevant modules. We have pandas as always, test train split, to split up the data, plotting, and here is then the model that we want to use. We load the data using the pandas functionality and have a quick look at the data frame. We can see that there are a number of feature variables, and this is our target variable, and we can see that the features are partly numeric and partly categorical. In particular, they are strings. One of the features of this model is that this can directly work with those kind of data, meaning with the strings and with the numbers, so we don't need to convert them beforehand ourselves. In the first step, we split our data in test and training set and use the scikit-learn functionality for this. And then we instantiate an instance of this classifier as our model. And since the package uses the same convention as scikit-learn, we can also call model fit on the train dataset. Instead of focusing on the predictions now, we want to focus on the model itself. We can have two ways to approach this. One is the global interpretation. That means how the model itself performs in the sense of which variables are important and what are the characteristics of these variables for the model as such. And then later we look at the local interpretation. That means the explainability for a single prediction. And because this is a white box model, we can then understand in more detail how a single prediction was. So let's start with the global interpretation. We do this by accessing the global method and use the convenience function show, which provides us with this interactive graph here. We start with a summary that lists which variables are important in which order. So the most important feature determining income is age. That in itself is not too surprising, because as we advance in our career, we necessarily also get older, and then we have the other variables. You can also look at the variables in more detail and look, for example, how the distribution of them behaves and how important they are. And then, maybe more interestingly, we have the local interpretation. Because this is a white box model, we can also look at the details of individual predictions. And unlike post hoc methods, where we need to do this with a black box model and sort of create a surrogate or a substitution model, this model is a white box model, so we can analyze the model predictions individually. We also have the same widget, but here we now create the local explanations for the first few cases of the test data. Of course, now there is no summary graph because we want to focus on individual data predictions. So we look at this one. So here we can see relative to, on a relative scale, how for this specific case, each of these variables contributed. Right. So we can see the variable status here has a strong indicator in this direction. The actual class was low income, and predicted class was also low income. And we can see how each of these variables affected this. You can also look at a different one. So as we said, these are now very different rows in our data set. This means that they correspond to different individuals. And as we can see, when we compare these, for example, here, that the order of the variables changes. Always the most influential ones are shown at the top, but also in which direction they point. If you go back to the other one, we can see that here we have a very different relationship of the variables compared to the outcome that we. You can also look maybe at this one, and here we see again both the order of the variables and the contribution of them is very much different